Hello everyone, it's Michael McClellan of Levine Electronics and Electrics. Hopefully you can see and hear me. Today we have a very special guests with us. We have Trey Mayfield and Abdu Barrow. And before they get started, we just have a few housekeeping items. This is a webcast format, so we can't hear you. Your phones are on mute. And so please use the question box in the lower left-hand corner of your window to ask questions. We would love for you to ask questions and participate. There's also a handout available on the lower left-hand side that is the presentation that Abdu is about to give. I've known Trey and Abdu for quite a long time, and everyone I've ever turned them on to has been very happy with their work. So without further Abdu, here's Abdu.
Thanks, Mike. Appreciate the opportunity. We want to go over a product that we have developed recently with in collaboration with PowerSide in California. My name is Abdu Barrow, by the way. I'm the general manager of EMA, and I have Trey Mayfield with me here, our drive specialist. So I am gonna take my camera off so I can see the presentation. Here we go. So this product we developed, there we go, is called DriveScan. We have a partnership with a company out in California that has experience in power quality monitoring and truly have been the standard in terms of testing and making power quality equipments, including the Fluke products. You know, they are the standard for Fluke products, and we use the same product and tailor it towards the needs of medium voltage VFDs. We have a combined experience of 50 years. They have a roughly 20 years experience, and EMA has about 30 years experience in variable frequency drives. PowerSide has sold about 50,000 power quality monitoring installations, and of course we have serviced more than 30,000 drives over the last 30 years. Some of the customers that we service, you can see here: Kinder Morgan, Marathon Refinery and Pipelines, Argos, Siemens, Velora Pipeline, Citizens Energy. So we service different segments of the industry, variable frequency drive industry, and these are other customers that PowerSide have serviced in the past as well. We have customers that that crossed over in both companies. Toshiba, for example, is a customer of ours and a customer of PowerSide. The product is geared to continuously monitor the health of variable frequency drives, and we came about with this product from our experience on predictive and preventive maintenance on medium voltage drives. We do significant amount of PM on medium voltage drives by sending technicians out in the field and performing these PMs. And based on that experience, we thought, okay, with the way artificial intelligence is available to us today, we can try to automate some of these functions and make it more effective than a person being on site. So this is Jason, one of our service engineers, as you can see here on a Siemens power module, and here he's taking a Toshiba power module out of a Toshiba medium voltage drive. And that's myself and Trey on a TBM, tunnel boring machine, New York City. IEEE did some studies and they found out that electrical installations that are subjected to PM are usually 3 times less likely to have failure compared to the ones that are not subjected to failure. So we know there is significant benefit to doing predictive and preventive maintenance. The whole goal is to improve your uptime, improve the drive reliability, and using artificial intelligence to trend and see what is going on with the health of these critical aspects of the drive can give us information where we can predict failure before it happens. This is a layout of drive scan and a medium voltage drive, so to speak. If we look at this, so we got our 4160 coming in, and here we have CTs that are reading the current and then sending it to the drive scan itself. And this is our ground current CT. And then we transform that medium voltage to low voltage with a PTs, open delta PTs, and we feed that into the into the drive scan. The drive scan can accept up to 600 volts AC. So that's why we cannot tie 4160 or 2300 or 6600 directly to it. We have to go through a PT. And in addition to that, we have a battery backup system here. And then we have our analog input modules where we can take analog inputs from the low voltage section of the drive. We have our fiber optic interface module that isolates the medium voltage to the low voltage section. So all of these are on our low voltage section, as you can see. And then on our medium voltage section, we have MVM modules that can take up to 2000 volts DC. So we can tie each of these to a power module on a VFD. For example, on a Toshiba VFD, we have 6 DC buses on a 4160 volt system, right? So that's what's showing as these 6 modules, and so the interface between the MVM modules and the fiber optic interface module is through fiber optic isolation, right? So therefore, we would not bring any interference between the medium voltage and the low voltage, and also safety, because if you have electrical wires, you could potentially, if there's a failure on the medium voltage section, you can introduce that medium voltage into low voltage, and we don't want to do that. So that's why we isolated with fiber optic cables. And then on our output section, we have similar configuration. We have PTs that are connected on our output, and then we send that back to our drive scan. And then we have CTs that are reading our current on the output side and sending the output current to the drive scan. So with this configuration, we literally can know the health of the drive without actually opening the doors of the drive of a medium voltage drive, which in reality we cannot even do. It's not allowed by code to open those doors while power is applied to the VFD. So that makes this tool very unique in itself, for the fact that we can read input current, we can read input voltage, we can read output current, output voltage, we can read DC buses, we can read our DC power supplies, and in addition to that, we can also read the temperature, humidity, and vibration of the VFD. And I will go into details on these things here. Mike, I'll give it to you for the poll.
Okay, great. Which poll would you like, Abdu?
The first one, which is the question about the PTs. Isolate the input of the. Can we connect 4160 or medium voltage to the input of the drive scan?
Okay, great. I just brought up the poll. Hopefully everybody can see it. Abdu, can you hear me?
I can hear you, but I don't know if they can hear you.
Yeah, if you can hear me, then they can hear me.
Okay.
Still haven't seen anyone voting yet.
Somebody raised their hand. I saw a raised hand earlier. I'm not sure. I can't click on. Won't allow me to zoom to see. But yeah, somebody raised their hand, so I'm guessing they have a question.
Okay. All right, let's just go ahead and move on. I'm going to close the poll, and unfortunately, and maybe we'll try another poll a little bit later.
Okay, sound good. Okay, so like I was saying earlier, so you know the drive scan can do gapless monitoring of the health of the VFD, including bus capacitors. We can look at the input power monitoring, which is your input voltage, input current, harmonics, input harmonics. We can also look at the output power monitoring, which is your output voltage, output current, you know, so we can look at all of those. We can look at the internal power supplies of the VFD on low voltage section, which is your 15 volts, minus 15 volts, 24 volts, 5 volts power supply. We can check the temperature of the cabinet. We can determine the humidity of the cabinet. We can determine the pressure inside the cabinet. And we can also determine vibration on the on these enclosures inside the drive cabinet. We offer what is known as a fleet monitoring 24/7. By the way, every monitoring that we do is 24/7 by the drive scan. It never rests, right? Like a person, this thing is always running and trending, taking data for us, and can store this data up to 2 years worth of data on the drive scan itself. And then we have a automated cloud analytic part of the drive scan, wherein we can look at significant amount of drives and summarize the health of the drive by using green, yellow, and red. But you know, if you have, for example, if you have 100 VFDs, and I'll go into details more, it's very hard to monitor and determine, look at all those reports, you know, that we get from drive scan. Each drive, we get 10 reports every time we have a problem with the drive. So, you know, if you can put that in perspective, that's 10 times 100, that's 1,000 reports every time you get a daily report, weekly reports, and so forth. So by using an automated cloud analytic based software, we can summarize and see where the problems are and narrow down or focus on those part of our system. On the grid side, if you ever have the Siemens medium voltage drive, this is a 1,000 horsepower frame, Gen 4. This is how it looks, right? So we have our phase shifting transformer, so we can look at the input current here. We can look at our input voltage coming from the grid and see if there's any problem as far as power quality coming in. We can look at our harmonics as well. We can look at the DC bus capacitors and the health of the power modules. On the Siemens medium voltage drives, usually they'll use 9 power cells or 12 power cells, depending on the generation of the drive. This is what we call cascaded brick topology. And, this is a whole different webinar if we want to go into details of how that works. And then we have a low voltage DC power supply, which is on our our low voltage section of the drive. We have our 24 volts, 15 volts, minus 15 volts, 5 volts power supplies in this compartment of the drive. We also have the environmental sensor that can read temperature, humidity, pressure, and vibration on the transformer section of the drive. Like I said, the topology is a whole different webinar, but the Siemens drive and others drive as well typically do not have what we call a pre-charge circuitry included in the drive. If you do not have a pre-charge circuitry on your medium voltage drive, the inrush current when you first turn power on can be 12 times the rating of that transformer. This causes significant amount of current, which then manifests itself into significant amount of flux, which then translates into vibration of the windings, because now we have 12 times the flux that these windings are rated for. As a result, that vibration of the windings can cause rubbing of the insulation. The rubbing of the insulation can then result into insulation wear and tear, and eventually transformer failure. As you can see on this picture here, this is a 3,000 horsepower Siemens drive that the transformer eventually failed. So this is very common on topologies where the design does not lend itself to reducing the inrush current by using a pre-charge circuitry. There are other manufacturers, medium voltage drive manufacturers, who use pre-charge circuitry to limit that inrush current, right? So because unlike low voltage drive design, where 99% of all low voltage drive designs are similar, every medium voltage drive is every medium voltage drive manufacturer uses their own design, unique design. All these designs are different. Now, until 2014, Siemens, which bought Rubicon, had locked in and had a patent on the cascaded hedge brick topology, which is the design we're talking about. After 2014, people have copied that design. So there are what we call Robi clones out there that basically use the same Siemens design, but there are other manufacturers that have a different design. And our drive scan, like I said earlier, we can take up from 9, well, actually from 1 all the way to 15 different DC buses, or in our case, power modules, right? So on a cascaded bridge topology, we have a single phase drive that are cascaded to produce the 4160. So we can do up to 15 of these, okay? And monitor each power cell and then feed it back to the intelligent part of the drive scan. We can look at the phase current, neutral current, which is your ground current, plus 15 independent DC buses. These are the DC buses we're looking at, as you can see here. So we can determine the ripple, we can determine the health of the power module from drive scan. And all of this can be done remotely, provided we have access to the drive scan, because we can put the drive scan, we can either give it an independent cell modem, a cell modem, where we provide you, the customer, with a dedicated cellular modem with an IP address where we can see it, you can see it, anybody with that IP address can see the drive scan, or you can put it on your network and put some securities in place wherein you can only allow people out of your organization to see or receive email, and they cannot get into your system, so to speak, as a security protocol. They can receive snapshots, and snapshots are problems. When there's problems, the drive scan will take a snapshot of the problem before it happens and send us all these 10 reports so we can look at it and determine what happened to the VFD. We can look at output current, output voltage as well, and all our low voltage power supplies, as I indicated earlier. This is a good example of a snapshot of a problem that happened on a drive scan. Typically, your three-phase input voltage should look like this, and so this looks really good, right? But if we look at our current, we have imbalance here, right? So once the problem is resolved, now we have balanced current, and this is how it's supposed to look. Now, if I log onto this drive scan at the time, I can actually see this, right? And say, okay, there's a problem here we need to address. Could be from the power company, it could be a loose connection or anything like that. And this also is a good indication or example of voltage sag that results into significant current draw, and then eventually the VFD tripped, right? And it caused instability on our DC power supplies, because when we lose power or the power dips, our power supply, the way drives work is that when a diode is turning on, the capacitor, which is, we have capacitors in our low voltage power supplies, we have them in our power cells and so forth. So the job of the capacitor is when the diode is switched on, is switching on, the capacitor will store charge. As the diode turns off, the stored charge on the capacitor will then provide power, and then that, this process keeps repeating. However, if we lose power, that means the diode is not turning on, right? Or there's nothing to turn it on. I mean, there's no voltage for it to turn on. So therefore, the remaining voltage that is stored, energy that is stored in the capacitor, is what is being used by the drive. And as a result, you can see a ripple even on our power supplies, on our low voltage power supply, and also on our DC buses here. This is our DC buses, as you can see. And then this is our line to line voltage, and this is our current, so at this point we are just losing current because of this problem. This is a picture of Siemens medium voltage drive. We have 9 power modules, therefore 9 MVM modules that are connected to the power cells, and through the fiber optic are sending data back to the drive scan in the low voltage section of the drive. This actually is a very interesting true story. We had a customer, Henry County in Georgia here, where they had a drive that was damaged, and a lot of times customers would ask us to give them at least analyze the drive and give them a reason why we think the drive failed. Well, in that particular case, the drive was so badly damaged, we could not do a good forensic analysis on the drive, and so we offered them this tool, this drive scan, on to install it on the adjacent drives, because their concern is, well, we may lose other drives because all these drives are about the same age. Well, as you can see here, we're looking at the DC bus of the drive. This was back in 2017. So everything looks good on the adjacent VFD, and then like I said, this one was in February. In March of 2017, sure enough, we saw some high-speed noise riding on top of our DC bus. Just so to give you an idea how drives are designed on our IGBT section, where when the IGBTs turn on and off, they produce significant amount of noise or overshoot. Okay. Now, this overshoot or noise is filtered by a snubber filter. We have a snubber network of resistors and capacitors inside the drive, and their job is to filter out high-speed noise, switching noise that is generated by the IGBTs. Then what happened in this case, as those snubber networks start to fail because of age and heat, you can see they're not able to do their job effectively. So as a result, we have 400 volts here in the positive volt DC, and we have over 450 volts roughly on the negative side. So combined peak-to-peak voltage of roughly 850 volts. Our DC bus capacitors are rated for 800 volts maximum on 460 volts power line. The reason that's the case is our nominal DC should be square root of 2 times the input voltage, which gives you about 650 volts nominal. So now, when we have a failure on the snubber network, we are now seeing 850 volts on those DC bus capacitors. What that does is it now punctures holes in the insulation of the capacitor and cause significant amount of leakage current, and as a result, capacitor failure. Now, this happens very quickly, as you can see. It happened here and then it stopped happening. So it shows us that this is a process. The filter, the snubber network filter, is failing gradually. And one of the things I told the customer is, if we had sent a service guy, one of our engineers, service engineers, to go look at this problem, the chances are they would not have been able to actually find a problem, because they're going to put a scope on the drive and realize, okay, well, let's say they put a scope at this time. The scope is going to come clean, not seeing anything. However, because DriveScan is continually recording this data, we are able to see every minute, and it's doing this at 30 milliseconds, every 30 milliseconds. So we're able to see what happened last week, 2 weeks ago, or even a year ago, right? So we can see a failure. So that actually was a savings, a huge savings for this customer, because we've seen a problem and predict a failure before it actually happened with the help of DriveScan. Okay, hence we call it a predictive maintenance tool. This is a snubber board out of that particular drive that blew up, as you can see. So this is the snubber capacitors, and these are your snubber resistors, right? So when the failure happened, it blew up the board, and then it blew up the capacitor. As you can see, this is a picture of 2 of the capacitors that came out of that particular drive. In addition to the functionality that we get out of this DriveScan, we can store all this data in the cloud and summarize the data for end users, so that they don't have to do a lot of figuring out. And I'll show you the reports that we get from DriveScan. So we call this a fleet management software, where, let's say on the pipelines, some of these pipelines have 1,000 drives, so that's a significant amount of data for somebody to sit there, one of our engineers, to look at every report. So rather than putting it in, giving it to someone to look at it, we can summarize and analyze that data in the cloud and give a summary form to the end user. Usually when we do a PM ourselves, we'll take measurements of these power supplies, the 5 volts, 15, -15, 24 volts, with our oscilloscopes, right? And we would look at the low voltage power supply capacitors. In this particular case, as you can see, these capacitors are bloated and they're discolored. So this is a manifestation of a damaged low voltage capacitor. Hence, when we look at them on a scope, we will actually see some ripple due to these issues because of the damages. As you can see here, the same thing here, these capacitors are damaged and this capacitor is good as well. I'm sure you guys have all seen power supplies before, and I have a simple power supply here where we take 120, step it down through a step down transformer, full wave rectification, and unfiltered ripple DC looks like this, right? So as I said earlier, when a diode, let's say in this particular case, we add a capacitor to our circuitry, right? So we add a capacitor here. The job of the capacitor is when this diode is turning on, the capacitor is charging, is storing charge. As this diode turns off, the capacitor now provides power. So we are supposed to get a straight line here if the capacitor is doing its job correctly. Now, as the capacitor is losing its capacitance, we can see these ripples develop, because now it's not able to do its job effectively due to losing, electrolyte or whatever reason it may be. So in this particular case, as you can see, we have 0.3 to 3 volts of AC ripple riding on top of our DC, and with time, this becomes more, and before it gets to a point where we get into a undetermined state, if we have a drive scan, we can actually see this and make a recommendation as to whether we should replace the power supply or at minimum replace the capacitors on the power supply. For example, this is a low voltage capacitor on the control board. So you can see this one is completely damaged until it has a hole in it. Oops, sorry. So like I said, when we put capacitors there, we're supposed to flatten, this ripple. This is a manifestation, as you can see, as the capacitor loses its capacitance, this is going to increase and eventually cause unpredicted operation on your electronics and on your VFDs as well, right? So on this power supply, this is a 12 volts power supply. We have roughly 0.35 volts of ripple. And then this one is pretty bad, about 1.26 volts of ripple. Like I said, on a drive scan, because it's continually trending, we can actually see this get worse. For example, we could see it go from 3.35 volts, gradually get into 1.27 volts, and and you can see it too because you have access to it. We can it will monitor our medium voltage drives and large low voltage drives 24/7. There's not a gap. It's continually recording this data, and so we call it gapless monitoring. And this example here I showed, for example, if we have we're missing a single phase in our cloud-based software, what would have happened in this case is we would see this red, okay? That means we're missing a single phase, and we would address that, and we can drill into this and actually see the actual voltage and the graphs that are coming into here, and I'll show you that. And of course, we'll see unbalance, right? Because if we lose a single phase, one of the phases here, we'll have an imbalance situation. This is on a Toshiba T300 MVI drive. We can look at input power and then output power. The same scenario. If we lose an output module, we will have a single phase going out of the drive. Or if we have a loose connection, our current will be imbalanced, right? And you know, so some of those things we can see without actually drilling into the actual data, you know, just by visual looking at the cloud-based software. The same applies to our low voltage power supplies. We can see our low voltage power supplies, the problem power supplies, 15 and minus 15 volts. We can see temperature, humidity, and so forth. In fact, the humidity, recently we had a customer out in Louisiana, a pipeline, where they had a drive down for 2 weeks on maintenance on the pump. And you know, the e-house, these things are on a e-house outside. So they had so much humidity and moisture during the shutdown. When they power up the drive and then start the drive right away, the drive blew up, right? Because there was so much moisture in the drive they didn't think about. And so once we went there, we realized this was the problem. So the drive scan would have they would have given us a warning, and if we want to, we can interlock it with the drive and not allow us to start the drive until that moisture reduced to an acceptable level. So the fleet management I was talking about earlier, as you can see here, this is a good example of a fleet management. So if you have like I said, 1,000 VFDs, you know, that you have to monitor. So if we, you know, that's pretty tough to even monitor, you know, to go through 1,000 drive scans, right? So, however, because of the way the analytic works in the cloud, we can actually see, okay, my drives in this pump station are all good. There's nothing wrong there. It's all green. So therefore, I'm not going to care about those. There's nothing here. There's nothing here. I can see there's one drive here that's yellow. So you know, if I click on that, I can drill in further and see what is happening to that drive. So the points of concern will be the yellow and the red indications, right? So those are the ones I need to put my energy in resolving. And of course, in this case, when I drill in, I can see over time how my DC buses are trending, right? And if I look at this, you know, these are all pretty much close, except my the green line or my W phase negative, you know, is looking like that's, you know, it's not following the trend that the rest of the buses are following. So that's an indication that there may be a problem on this power module. And if we have, if I set windows and limits to this on this drive, I would have gotten an email saying, okay, there's a problem on this power cell and you need to look at it and correct the problem. These are some of the things we can look at. This is actually on our drive scan here. You know, as you can see, it's a Toshiba drive, firmware version, IP address, the power configuration is Delta, 4160, 60 Hertz, and so forth. And I can also look at my power supplies here and my input voltage, output voltage as output current, input current, input voltage, and these low voltage DC power supplies. You can see all of them. My 5 volts power supply is roughly 4.96. 15 volts is 14.84, minus 15 is minus 14.96, so and so forth. So I can see what is actually going on with my drive. And when I took these snapshots, I don't have 4160, so you can see I'm missing 4160 here. I can look at my line to neutral voltage, my phase angle, and so forth. You know, I can look at my harmonics. I can look at my waveforms, my DC ripple ratio, actual ripple. So I can look at all of those as you can see here. So that's showing me my ripple. This is trending my line voltage, line to line, my current, my frequency, harmonics here. And when I drill into more, I can actually look at the raw data. This is giving me my raw data, 4.245 kV, L1 to L2, and so forth. And I can look at my current as well, I can look at my ripple percentage as well, my frequency, my power usage, reactive power, and so forth. So I can look at all of this information. This is one of my customers' drive, medium voltage drive. So we can see a significant amount of data from the drive scan. And this is the harmonic data and so forth. So I can see all of those real life time. One of the things I had mentioned and have it on this slide as well, this is all happening at 30 microseconds, so very quickly. It's very fast. So we can see what, some of you may already know this, but what we call ultra harmonics. These days we have so many switching devices that our grid and our facilities are bombarded with harmonics. So we can now see ultra harmonics with this device. So it's very, in those cases, very useful in terms of how quickly it can read this data. Mike, this will be another poll question if you can hear me there.
Yeah, I can hear you.
This is the second poll question.
All right, looks like about 60% of you voted.
All righty. All righty. Just to share with you guys what EMA does. EMA have been in business for roughly 30 years. We repair variable frequency drives, both low voltage and medium voltage drives. We repair and service soft starts, both low voltage and medium voltage. We repair and service motor protection relays, transformer protection, and also feeder protection relays, 750s, 369, 469s, the product that John and Mike sells. We service all of those. And over the years, our customers have given us some feedback. This is actually from Henry County Water here, where they have these drive scans. And one of the feedbacks we got from Henry County is that, they love the product, and in terms of troubleshooting, they don't even have to put on their arc flash suits anymore, because they can actually troubleshoot the drive from the convenience of their computer. They don't have to go to the drive. They just log onto the computer and can see what is happening on the drives. So they are very impressed and bought significant amount of drive scan and put it on all their large VFDs. We do a significant amount of work for Argos Cement, which used to be part of Lafarge Cement, and this is a testimonial from them in terms of the work we have done for them on their medium voltage drives in South Carolina. And then this is another manufacturing plant out in South Carolina, where we've done significant amount of work. They used to bring service techs from Europe to help take care of their problems, drive problems and PLC problems in the States here. But once they found us, they have saved significant amount of money in terms of downtime, because now they don't have to have a technician fly from Europe to here. We take care of all their drive needs and PLC needs. And then this is another testimonial from United Water out in Indianapolis, where we do a significant amount of work on their Rubicon Siemens drives and ABB drives as well. And then, of course, another testimonial we have here is from a customer in Seattle, Kenmore area, where we have done some work on their tunnel boring machine VFDs. So if there's anything that we can help you in terms of drive service or drive predictive and preventive maintenance, both in person or using drive scan, certainly we would welcome an opportunity to work with L3 to make your drives, increase your uptime in terms of your factory utilization. Mike, on the questions, I guess, how do we see that? I know they're muted.
Okay, at this point, we'd like to open it up for questions. And I'll read them to you as they come in. Okay, here's one. Does EMA offer maintenance contracts?
Yes, we do.
Okay, can you give us some details on what that contract might look at?
So, we have a maintenance contract with, for example, City of Atlanta, United Water, Indianapolis, and usually it's customized to the customer's needs, specific to VFD. So that will include negotiated rates, field service rates, and also we will respond as far as when they have a problem, 30 minutes in terms of calling them back, no later than 30 minutes. And it also includes free tech support. Sometimes we have, if they order parts before they have a damage, meaning they stock certain parts, we can negotiate that, give those parts to them at a discounted rate. And it could be anywhere from 1 year to 3 year or 5 year contract.
Okay, great. Next question is, where are you located?
We're located in Norcross, Georgia, which is a suburb of Atlanta. We have an office in upstate New York, but we do provide service all across the country and overseas. We have customers out in the Middle East. We have customers in Canada. We have traveled to South America. And so at the moment, actually, we have a service engineer in Missouri at the moment. We have one in Nevada. And one in Ohio. Okay, so at any point in time, our service guys are anywhere from here to California or Middle East. So we can travel wherever there's a need for drive service.
What's a ballpark price on to install the drive scan onto an existing drive? Plus or minus 30%.
So as far as the installation costs, roughly, depending on where you're located, right? So roughly around $4,000 to $5,000 is what we've seen. If it's local in Atlanta here, it would be less than that, right? Because there's no airline costs, and but if we have to fly, then you're looking at roughly $4,000.
Great. That includes all the equipment, programming, commissioning. That's from start to finish.
No, that's just the labor to install it. Now, the equipment varies. For example, the Siemens drive can have 9 cells, 12 cells, 15 cells, and so forth. So the Siemens drive, on average, on a Siemens medium voltage drive, is about $20,000. On a Toshiba drive, it's about $15,000 for the equipment. And on a low voltage drive, it's $7,000. So it all depends on the drive. So we need to know what drive we're looking at to give you a good idea on pricing of the equipment side.
That makes sense. And that's a lot cheaper than trying to find that drive in an emergency. So
exactly. And also, like I said, the ability to predict failure before it happens. And also, if you think about it, in certain cases, we can actually troubleshoot the problem remotely, right? For example, if you are in California and you call me and said, my drive is down, where we had that happen. We had a customer in California where they were down and they called me and needed somebody there right away. We had a guy flew to San Leandro, which is a suburb of San Francisco. He got there. There was nothing wrong with the drive. He push a reset. The drive run. He sat there and then flew home the next day. That cost the customer about $20,000, including on a weekend call, right? So, and that problem could have been determined from a drive scan, looking at what is happening with the drive. We could have said, okay, there's nothing wrong with the drive. It's power up. It's ready to go. And he could have reset the drive and up and running the same day. And so those are some of the things that the drive scan brings to the table for customers compared to having a technician fly. So not only do you have the ability to predict failure, but you also have a remote tool that can help you diagnose problems and troubleshoot your drive and get you up and running quicker. Fantastic.
Next question came in is EMA available for a tour? Like, could I come by and take a tour?
Certainly, we invite customers all the time. Just let us know ahead of time, and you'll be welcome to tour our facility.
You see a drive scan in person.
Yeah.
Okay, so you do have a drive scan on site where they could see it in person?
Yes. In fact, we have a drive scan. I think we're out of time here. Otherwise, I can actually log on to it now, and you guys can see a drive scan. I mean, it's not running. If we have time, we can run the drive, and you can see what is happening and all of that. Or I can share the IP address with you, Mike, and you can give it to them. They can log on, given that we're running out of time here.
Well, I think it's okay if we go over 5 or 10 minutes. I think these folks are interested in seeing all the moving parts. While you're doing that, the next question that came in is, what type of connection do you need for the drive scan? Do you need to get it back to an Ethernet or a cell phone? And does EMA handle that?
So we can do all of those. We can do cell modem, Ethernet. Wherever you have an Internet connection, you can connect it to the drive scan. As far as can EMA do all of that, we can do cell modem. We can provide it with a cell modem. But if you have a network already in your facility, of course, we can help you set it up and put it on your network, right? But yeah, we can provide whatever is needed to yeah. So we can certainly do that. And I don't know if you guys can see my screen at the moment.
Yeah, we see it.
Okay, good. So let's go ahead with the questions. Once we finish the questions, I can go through this. This is actually a drive scan that's connected to my medium voltage drive now.
Okay, last question is, what's the best way to predict a capacitor failure in a Siemens medium voltage power cell?
That's a very good question. So the capacitor failure, as the capacitor loses its capacitance, electrolytic capacitor. So Siemens use electrolytic capacitors in their drive. So as the electrolyte loss increase, which happens due to heating effect in the drive or ripple current in the capacitor, it will manifest itself in either leaking the electrolyte out of the can, which then manifests itself as also ripple, because now we don't have as much electrolyte inside the can, or as it dries. Sometimes it doesn't even leak out, it dries inside the can. Again, that manifests itself as ripple. So we are continuously monitoring the ripple ratio with drive scan, and by so doing, we can actually know a failure before it happens. So this is an example on my drive, and give me a minute. They're putting 4160 on my drive, and they're going to run it here so we can show you some of this. So if we look at this, this is actually my DC bus on the Toshiba. This one is on the Toshiba medium voltage drive. You can see at the moment it's off, right? And then over here, we'll see the ripple, the amplitude of the ripple that is riding on each DC bus. And this is actually my ripple ratio on each DC bus. So with all this information, I can decipher, or I can put in limits on the drive scan to tell it, okay, when we hit these limits, I want you to send me a report or an alarm saying, hey, my capacitors are getting to a level where we need to consider replacing them. So we can predict a failure before it happens. Okay,
is Trey out there pulling the
yeah.
pulling the string to start the engine?
Yep. He went there to do that for me.
Here's another question while you guys are doing that. Is the communication with the drive one-way or two-way? I think he's asking if it's possible to control the drive.
Drive scan, you mean? At the moment is one way as far as sending us data. We can put in commands and things like that. Let me see. I'm terrible with passwords. I'm sorry. I have to look at the password here. Sorry, I have to look at the password here to see. That's why I write it down. So we can put in limits. If we go under commands, we can put in limits. We can tell it to generate reports. But there's one digital output where we can also tell it to, if these conditions happen, I want you to shut down the drive, right? If these conditions happen, so from that perspective, it can control the drive, and then of course at the same time we can send data back to us. We can we can talk to it with Modbus, Ethernet IP address, and BACnet. Those are the three protocols that it understands.
Another question came in. Can you give us an idea of the monthly monitoring fees?
So the monthly monitoring fee depends on the number of drives that you're going to monitor, but an average of $300 a month is what we're asking for now. We have a special going on because we're just developing that cloud-based monthly monitoring software, right? So we have a 2-year trial, or free, 2-year free, if you subscribe this year and anytime this year, and then you'll have 2 years beginning 1st of January. And after that 2 year, if you don't like it, you can unsubscribe. If you like it, you can keep it. So we have that special going on now. So we are not able to run the drive because it appears they're testing something on the generator or the test on the drives. So I apologize for that, but we can look at events, for example. So what some of the things that I said, so the drive scan will store up to 2 years worth of data in the drive scan itself, in this hard drive. And so if I go back to it, I can look at what happened on the 5th on this drive. And if I click on this, so it gives me each occurrence of a problem or snapshot, gives me all this data. For example, I can look at the waveforms of the drive. I can look at the DC bus, the power supplies, and all of that. So I can look at all of those. I can go back and look at what happened at what day and what time. So this is all data that is readily available in the drive scan. So it gives me GFI, CVS files, basically Excel or CSV files. Okay, still downloading the file, but so I can look at all those information after an event happened, and also based on this data that is being trended real time for so many months, you can see a deterioration on, for example, your 5 volts power supply. So this is data that we can look at here. Okay, so my 5 volts power supply, 15 volts minus 15 volts, and it gives me my the moment I get no power, so everything is almost zero. Power supplies, my ripple, my ripple DC is all zero because at the moment we have nothing nothing powered up, and I'm sorry about that. I thought we could look at those, but it appears we're not able to do that.
Oh, that's okay. Well, what we'll do is we'll do another webinar in a few weeks devoted completely to the software.
Okay.
And that way you can take everyone through the software in a very thorough manner. But it was a great presentation, Abdu. I think it gave everyone a nice overview of what you're offering, and I think we've completed all the questions. So thank you all so much for your attendance, and thank you again to Abdu and to Trey, and I hope everyone has a wonderful day.
Appreciate the
Thank you.
opportunity. Thank you, Mike.